All right, this video covers the exam 3A review, numbers 1 to 7. All right, number 1 here, we've got a quadratic function, and we want to state the direction of opening, the vertex, the intercepts, and the axis of symmetry. So beginning here, this parabola opens up. I can tell that because the leading coefficient is a positive 1. And so if your A of ax squared plus bx plus c is positive, your parabola is going to open up. If it's negative, it'll open down. Next, I'm going to find the vertex. To find the x-coordinate of the vertex, I'm going to use the formula x equals negative b over 2a. B in this problem is negative 6, so if we negate that, we'll get a positive 6. And then as we saw when we said that the parabola opens up, our A is a positive 1. So it looks like the x-coordinate of the vertex is 3. Now you do still need to find the y-coordinate as well, and we find that by plugging 3 into the equation for x. Oops. Sorry, should be a 3, not a 2. All right, plus 8. Oops, don't know what happened there. Try that again. All right, so we have 9 minus 18 plus 8, which would be negative 1. So it looks like our vertex is the point 3, negative 1. Because our parabola opens up, the vertex will be the lowest point on the parabola. The x-intercepts are found by substituting 0 for y. This is because the y-coordinate of every point along the x-axis is 0. And we can solve this equation by factoring. I'm going to look for two numbers that add to negative 6 and multiply to 8. Those two numbers would be negative 4 and negative 2. I don't know why my pen is doing this. All right, so we'll set each of these factors equal to 0 and solve. So our two x-intercepts are 4, 0, and 2, 0. So I just set each of these factors equal to 0. I'm writing them as ordered pairs. To find the y-intercept, we plug in 0 for x. So this would be 0 squared minus 6 times 0 plus 8, which would just be 8. So our y-intercept is 8. As an ordered pair, that would be the point 0, 8. And then finally, the last thing we're going to find before we graph is the axis of symmetry. I'll write it over here. I'll call it AOS for axis of symmetry. The axis of symmetry has the equation x equals negative b over 2a. This is because it's a line that runs through the vertex. So it's going to be x equals whatever the x-coordinate of the vertex is. So our axis of symmetry would be x equals 3. Sorry, my pen is going kind of crazy here. So x equals 3. I'll dash it in. It's actually not part of the graph of the parabola, but it is the line about which the graph is symmetrical. Okay, so let's plot. Our vertex is at 3, negative 1. I mentioned this is going to be the lowest point on our graph. Our x-intercepts are 2, 0, and 4, 0, so we'll plot those. And we also have 0, 8. 1, 2, 3, 4, 5, 6, 7, 8 is our y-intercept. Okay, I mentioned this is our vertex. It's the low point. And so it's a U-shaped graph. It's going to come down and, oops, sorry, it's a little crooked there. Come down, touch that vertex, head back up in the other direction. I will dash in the axis of symmetry. You don't have to if you don't want to. It isn't part of the parabola, but it is the line about which the parabola is symmetrical. So this is our axis of symmetry. It is important that you write x equals 3 and not just the number 3. It is the equation of a line. It is not just a number. It's the equation of a vertical line. Okay, well, let's see another one now. Okay, this one opens down. I can tell that right away just by looking at the equation because my leading coefficient is -2. A negative leading coefficient means your parabola will open down. To find the vertex, I'm going to do the same thing. I'm going to start and find the x-coordinate of the vertex by using the formula -b/2a. Looks like b is a -16, so if I negate that, I'm going to get a +16. And then 2 times a, 2 times -2 is -4. So we have to take 16 and divide by -4 to get -4 as the x-coordinate of our vertex. To find the y-coordinate of the vertex, we plug -4 into the equation. All right, let's see here. This would be, so this is -2 times +16. That's going to be a -32. It is +16 because when you square a -4, +16, plus 64, because we're subtracting, but what we subtract is a -64, so same thing as plus 64, minus 24. So let's see, -32 plus 64 is 32. 32 minus 24 is 8. So it looks like our vertex is the point -4, 8. This time our vertex is going to be the highest point on the graph since our parabola opens down. To find our x-intercepts, we substitute 0 for y and solve. And to factor this, I noticed that all terms are divisible by 2. Actually, I can do -2. It would be a little easier to factor. So what I'm going to do is I'm going to divide both sides of this equation by -2. I'm just trying to make it easier on myself on factoring. So I'll now have 0 equals x squared plus 8x plus 12. And then I can see that I want to come up with two numbers that add to 8 and multiply to 12. Those two numbers are 6 and 2. And then if I set each of these factors equal to 0 and solve, I've got my two x-intercepts. I'm going to write them as ordered pairs. We've got the point -6, 0 and -2, 0. Go over here, so I'm running out of room here. To find my y-intercept, I substitute 0 for x. Make sure you substitute it back into the original equation. This is not, I mean, when I set y to 0, I was able to divide through by -2. But when I'm going for my y-intercept, I do want to make sure I plug 0 into the original equation, the original function. And so I'm just going to get -24. So y equals -24. So y-intercept would be 0, -24. And then my axis of symmetry is just x equals whatever the x-coordinate of the vertex is, because it is a vertical line that runs straight through the vertex. So x equals -4. Now when I go to graph this, I'm going to plot my vertex, -4, 8. My y-intercept is way down here. It's off the graph. If I continue and I scale the y-axis by 1, but I could scale the y-axis by, 4 or 3. 4 might be good because these are all divisible by 4. You could also, if you wanted to, and I believe on the answer key, I scaled my y-axis by 4s. But the other thing you could do is you could just not plot the y-intercept. So you could plot, here's -4, 8, 1, 2, 3, 4, and then go up to 8. And then you could plot your two x-intercepts, -2, 0, and -6, 0. And then you could just draw your parabola, sorry, whoa, hard to sketch here, where you don't even plot the y-intercept. So it's completely up to you. You could do it like this. I did not rescale my y-axis. I just went by ones. Or you could do what the answer key does, which is plot the y-intercept and scaled by, I think, 4s is what the answer key has. All right, on to number 3 now. We are supposed to express this parabola in vertex form and then state the vertex. So this is vertex form here. In order to put this quadratic function into vertex form, we do need to complete the square. And before we complete the square, we do have to factor a from the first 2 terms, because notice there's an a in front. So I'm going to factor out the 5. I'm going to take it from x squared, or 5x squared, and then also 30x, which would leave me with a 6x. I'm going to then close my parentheses because I did not factor 5 from -3. So I close my parentheses. Also want to point out that although you can also remove an x, you do not want to. Notice that this vertex form does not have an ax out there, just an a. So we want to leave this as x squared plus something x. Okay, now we're ready to complete the square. So to complete the square, BTS, complete the square, we take the coefficient of x, which is 6, we divide by 2, and we square the result. So 6 divided by 2 is 2, or sorry, 6 divided by 2 is 3, and 3 squared is 9. So I'm going to add 9 inside the parentheses here. I'm going to leave a little bit of room here because we'll talk about what we need to add to the other side. So by adding a 9 inside the parentheses, what I've done is I've created a perfect square trinomial. That means I can factor this into the square of a binomial. Now, whatever we do to one side of an equation, we also have to do to the other side. And you did add 9, but you put it inside parentheses, and there's a multiplier in front. So by adding 9 and putting it inside the parentheses, you actually added 45 to that side of the equation. I'm getting the number 45 by distributing the 5 to the 9, or multiplying 5 times 9. So in order to keep the balance, I need to add 45 to the other side of the equation. Okay, we're almost done here. Now I mentioned that we can factor this perfect square trinomial into the square of a binomial. That binomial is x plus 3. Just think of 2 numbers that add to 6 and multiply to 9, 3 and 3. And then we also need to isolate our f of x. I'm going to subtract 45 from both sides. So my answer is f of x equals 5 times the quantity x plus 3 squared minus 48. Now this problem also asks us to state the vertex. Once we have our equation in vertex form, the x-coordinate comes from inside the parentheses, although it is the opposite sign of what you see. It all has to do with the fact that inside the parentheses, we have an x minus h. So we think of this as x minus -3 instead of x plus 3. So opposite sign, but then we do use the same sign that we see outside the parentheses. So this is our x-coordinate, opposite sign, and then same sign. And it all has to do with the fact that we've got a minus h inside the parentheses, but a plus k on the outside. All right, number 4 is very similar to number 3. It's another parabola. This one opens down though, since we have a leading coefficient that is negative, but the process really is the same. All right, so the first thing we do is we factor out our a, which is a -4. When you factor a -4 or take out a -4 from a positive 16, it does change the sign. So we've got -4, -4x or -4x. Then we're going to complete the square just as we did in the previous problem. To complete the square, we take the coefficient of x, we divide by 2, square the result. So we have negative 2 squared, which is 4. I'm going to add 4 inside my parentheses. I'm also going to leave a little bit of room over here because I've got to make sure I do to the left side what I've done to the right side of the equation. So just as we saw with number 3, we have a multiplier in front. So by putting plus 4 or adding 4 inside the parentheses, we actually subtracted 16 because if you distribute the negative 4 to the 4, you get negative 16. So in order to keep the balance, it's going to be subtract 16 from the other side or add a negative 16 if you want to do that. All right, then we will factor our perfect square trinomial that we created inside the parentheses. We're going to factor it as the square of a binomial. That binomial would be x minus 2. And then we need to isolate our f of x. We're going to add 16 to both sides. We get f of x equals negative 4 times the quantity x minus 2 squared plus 6. Vertex, opposite sign, positive 2, same sign, 6. So 2, 6 would be the vertex of this parabola. I always tell my students that you can always check your answer too if you have time. You could go back and do it the other way where you find the x-coordinate of the vertex by taking negative b over 2a. If you go back to the original equation here and use x equals negative b over 2a, you're going to get 2. And then if you plug 2 into that equation, you get 6. It's a great way to check your answer. Okay, now we're going to look at some composite functions here. So this one we have 2 functions here. We're supposed to find first f of g of x. To find f of g of x, as you can see from how it's written, they want us to take the function g and plug it into f. And I'm going to plug it in where I see the variable x. So this becomes 6 times, not x squared, but the function g squared minus 5. When we square a binomial, we do have to FOIL. We can't just square each of the terms of the binomial. I also can't distribute the 6 in step 1 here. I've got to write that twice before I distribute the 6. Now at this point you could distribute the 6 if you wanted to, but I'm going to go ahead and continue with foiling here. So I'm going to get 16x squared plus 28x plus 28x plus 49. So I'll have a minus 5 here. I'm going to combine like terms inside my parentheses to get 16x squared plus 56x plus 49. Then I can distribute my 6. So 16 times 6 would be 96. 56 times 6, oh boy. Okay. I'm going to pull up my calculator here. Where is my calculator? There it is. Okay, so let's see. I want to take 6 times 56. So that's 336 x plus 49 times 6, 294. These are some big numbers. All right, and then minus 5. So final answer after combining like terms would be 96x squared plus 336x plus 289. Okay, but then it also asks us to find g of f of x. This one, g of f of x, actually won't be quite this long. So in this case, we want to plug f into g this time. So this time, I'm going to take this function f and plug it into g where I see my x. So 4, but then in the place of x, I'm going to put in the function the function f. So I'm going to replace x with the function f. And then this one is quicker because I don't have to square a binomial like I had to in the first part. I could just go and distribute my 4. Uh-oh. There my pen goes again. All right, so 24x squared minus 20 plus 7. Oh, goodness. I don't know what's happening again. All right, plus 7. All right, combine my like terms. Final answer, 24x squared minus 13. All right, so that one was a little bit faster. All right. Look at 2 more on this video, 6 and 7. 6 is also asking us to calculate 2 composite functions. The notation is a little different, but we can turn it into the same notation as we saw for number 5. So if you're asked to find f circle g, that is the same thing as f of g of x. So again, we want to plug the function g into f. So I'm going to take this function here, plug it into f where I see the variable x. So it becomes the square root of 3x squared minus 2 plus 7. So I'm replacing the x in the equation with the function g. I can combine like terms to get 3x squared plus 5 under the square root, and that's all I can do with that. So the square root of 3x squared plus 5 is our answer. If we want to find g circle f, this is the same thing as g of f of x. So we're going to go the other way. We're going to take the function f and we're going to plug it into g. So this time, this function here goes into g where we see the x. Now the x is squared. So when we plug in the function f, we are going to square it. And when we square a square root, the square root disappears, and we're just left with the radicand, which is x plus 7. Then we can distribute our 3 and combine like terms for a final answer of 3x plus 19. Okay, one more problem on this video, number 7. So this one gives you 2 rational functions, and it asks you to find f plus g, f minus g, f times g, and f divided by g of x. It also asks for the domain of each. All right, so let's start with f plus g of x, which is equivalent to f of x plus g of x. So I'm going to take the function f and add g. Now, anytime we're adding 2 fractions, even if they're rational expressions like these are now, we need a common denominator. So I'm going to multiply the first rational expression here, or the function f, by x plus 4, both numerator and denominator. And over here, I'm going to multiply both the numerator and denominator by x minus 2. This is going to give me a common denominator. All right, so now I'll go ahead and distribute as well. X squared plus 4x over x minus 2 times the quantity x plus 4 plus 3x squared minus 6x over x minus 2 times the quantity x plus 4. Now that I have a common denominator, I'm going to add my numerators and retain that common denominator. So I'm going to take x squared plus 4x and add 3x squared minus 6x and put that sum over my common denominator. After combining like terms in the numerator, I have 4x squared minus 2x. All right, so this is my answer for f plus g of x. You could factor that numerator if you want to. You could factor out a 2x, but it is not going to help you to reduce this at all. So up to you. You're welcome to factor in the numerator, but this answer is just fine. Okay, let's talk about domain with this one. For the domain, since division by 0 is undefined, we don't want either of these factors from the denominator to be 0. So this means that our domain is all real numbers except 2 and negative 4. So domain is all real numbers except 2 and negative 4. Because 2 and negative 4 would result in a denominator of 0. Now, I typically just write x cannot equal 2 or negative 4. I usually write it like this. Sometimes your instructor might want you to put it in interval notation, although it won't specify that on the test. However your instructor likes you to do it, I usually just write x cannot equal. So I mean all real numbers except for 2 and negative 4. Okay, next, let's do f minus g of x, which is the same thing as f of x minus g of x. Now, since we already did the work above to get a common denominator, I'm just going to go right here to this step and just change this plus sign to a subtraction symbol. So I'm just going to change that because I've already done the work to get a common denominator. So we have x squared plus 4x over x minus 2 times the quantity x plus 4 minus 3x squared minus 6x over x minus 2 times the quantity x plus 4. Okay, so now I'm going to subtract numerators, retain my common denominator. Be careful on this one. When you subtract numerators, you do want to subtract all terms of the second numerator. I'm going to subtract the 3x squared. I'm also going to subtract negative 6x. When you subtract a negative, though, it changes to positive. So it's actually going to be plus 6x there in the back. Oops, don't know what happened there. Over my common denominator. And then sorry, that's a 2 there. For some reason, my pen is going a little crazy. All right, so after combining like terms, in the numerator, I have negative 2x squared plus 10x. Oh, goodness gracious. There we go. Okay, plus 10x. Oh, Lordy. Okay, my pen has gone crazy here. Let me pause the video for a second. Okay, let's try now here. So I've got negative 2x squared plus 10x over my common denominator. This answer is great. If you really, really want to, you could factor the numerator. It is not going to help you to reduce it all, but you could factor out either a 2x or a negative 2x from that numerator. Our domain is, once again, that we do not want x to be 2 or negative 4. 2 would make this factor 0, meaning the entire denominator would be 0. Negative 4 would make this factor 0. So same domain as we had above. All right, now we're going to multiply and divide. I actually moved this down here. I'm going to go back because now I've kind of lost the original problem. So let me go back up here. So I've got two more here. I'm going to do f times g and then f divided by g. All right, so if I want to find f times g of x, this is the same thing as f of x times g of x. So I have x over x minus 2 times 3x over x plus 4. And this is actually the quickest of all of them because you do not need a common denominator when multiplying two fractions or two rational expressions. You just multiply straight across. So you multiply the numerators, you're going to get 3x squared, and then you multiply the denominators. X minus 2 times the quantity x plus 4. That's it. You're done. Domain is actually the same as it has been for the other two operations that we've done. X cannot be 2 or negative 4. Okay, one more operation, division. So we've got f divided by g of x. This is equivalent to f of x divided by g of x. So we've got f of x divided by g of x. Instead of writing this vertically like I have, I'm going to write it horizontally, although I do always like to write it vertically first because I feel like it helps with the domain. So here we have it vertically. We're going to try to reduce if possible or simplify. Well, we can definitely simplify. We can get rid of that complex fraction there. But I wrote it as f divided by g, so I wrote it horizontally here. And when you divide, you can multiply by the reciprocal of the second fraction. So I'm going to multiply by x plus 4 over 3x. And the one thing that we can do to simplify this is we can cross-cancel the variable x. We've got an x in the numerator of the first rational expression and then an x in the denominator of the second one. So our answer is x plus 4 over 3 times the quantity x minus 2. Now the domain of this one is a little tougher, and if you just look to your simplified answer, you are not going to get the correct domain. So the way I explain this is I tell students to go back to your unsimplified answer and just make sure that no denominator anywhere in this unsimplified answer is 0. So I see a denominator here. I got to make sure that denominator is not 0. I see a denominator here. I got to make sure that denominator is not 0. And I also see a denominator here. That's the entire denominator. So there our domain is going to be all real numbers except for 3 numbers. So let's see what those 3 numbers are. I don't want x minus 2 to be 0, so I don't want x to be 2. That's not a surprise. That was part of our domain for all the other ones. I don't want x plus 4 to be 0, which means I don't want x to be negative 4. Okay, not a surprise. We had that before. But there is an additional number, one more number that we're going to remove from the set of all real numbers when we state the domain. So I don't want 3x over x plus 4 to be 0. Now you may just recognize that this fraction will be 0 when the numerator is 0, but if it's not obvious, you could multiply both sides of the equation by x plus 4. And you can cross cancel here. So 0 times anything is still just 0. So we don't want 3x to be 0, which means that we don't want x to be 0, because I could divide both sides by 3. All right, so our domain will be all real numbers except for 2, -4, and 0. So we see that the domain, there's actually one additional number that we want to remove from the set of all real numbers. So we don't want x to be 2, -4, or 0. All right, guys, well, this concludes this video, but check out the next 2 videos for the rest of the problem. Thanks for watching.